Good morning, everybody. I'm honored to be here representing my institution, United Nations University e-Government Operating Unit, and to be able to talk to you about the prospect of non-traditional data and computational science for sustainable development is mine, and I really acknowledge it. My name is Moinul Zaber. I'm a senior academic fellow of United Nations University, and welcome to my talk. Before we start, I would like to talk about a little bit about my institution. It is United Nations University is a very old university actually, and we at EGOV is it's an institution where we basically work on electronic governments, and it is based in Guimarães, Portugal. And as you can see, that these are the areas where around the world we have been working. We are currently working with China as well, and our focus is actually on sustainable development, social inclusion, and active citizenship. So today's talk is mostly about sustainable development and data. So we know about Sustainable Development Goal, SDG goal, which actually set to ensure that no one is left behind. It has to be uh, achieved by 2030. That's the world's goal. And actually, what happens is like SDG has 17 different goals based on 169 targets that are classified into three tiers. So these are these tiers: tier one, two, and three. And tier one are the indicators that are conceptually clear. They have established methodology and available for anyone in this world to actually pursue. And these data are regularly produced by different countries, at least 50% of the countries. Tier two indicators are the indicators which are also established methodologically. However, they are not regularly produced by countries. Tier three are the indicators which are, I would say, are not really established. They are not established as in because many countries actually doesn't. It is still under research. So that's why last year in March, in the 51st UNSC, which is United Nations um, Organization for Statistics, they basically decided to take down the tier three indicators. Um, in, so as of 28th December 2020, the updated tire classification contains about 130 tire indicators, 97 tire, 130 tire 1 indicators, 97 tire 2 indicators. So we actually see like there are a multiple number of indicators that are based on data, and that we actually need these are these are required for us to understand how good or bad the governments are doing. So it means that we are really focusing on collecting and disseminating data. Now let's talk about government, development, and economy. Now, what is a government? Government is an institution through which leaders exercise power to make and enforce laws. Government's basic functions are providing leadership, maintaining order, providing public services, providing national security, providing economic security, providing economic assistance. Now, uh, in doing so, the government basically looks at the economy first of all. We know that if the economy is doing well, then the whole country should, as a whole, should be doing better. Now, if we look at the factors of economy, there are like multiple factors. Some of them are producers, some of the distributors, consumers, laborers, resources, capitals. So now that we know about how the government actually, what is the purpose of a government, and then we know that who are the actors of economy, we actually need to think about like what is meant by good governance. So, but actually, in a nutshell, good governance is a way to say that the country is doing well economically. So the transactions that happen between those actors that we actually talked about in the previous slide are working well. This will improve the quality of life of the people living in that in that state or country. Now, how do we measure that? I mean, why, first of all, why do we need to measure it? Because if we don't measure it, then we won't be able to know how to improve the quality of life. And recently, we actually have found that, with the I mean, advent of new technology, we have different new sources that actually help us to actually gather better data, and that's why we are now saying that data driven good governance is a solution that can actually enhance the standard of our lives faster than we could actually ever think of. So let's talk about traditional data now. Traditional macro data that actually talks about the whole country or whole nation as a whole consists of quantitative measures that describe a country's situation in a given economic, social and other dimension in a certain period of time. Mm, and it can actually help you to see how we were doing in past and how we are doing in present. Macro data are usually official statistics produced by official organizations like the Statistical Institute of the country, or intergovernmental organizations such as United Nations, World Bank, OECD, etc. Most well-known macro variables are GDP per capita, we all know it, inflation rate, unemployment rate, interest rate, etc. Um, there are um, several other micro indicators that related with dimensions such as business environment, human capital, technological diffusion, institutions, and development. They have appeared and gained importance in last decades, reflecting the challenges that globalization, internationalization, digitalization, and new technologies have brought to the world economy. Um, Now, macro data constitute the basis of country-level empirical research, either descriptively or econometrically. Without quantitative indicators, it would be very difficult to assess a given country's evolution in several economic, social, and demographic dimensions. Um, so, a detailed knowledge of the data is often a precondition for good economic management. And the macroeconomic data are and the indicators are the way to actually help us to compare between countries. And this actually helps the investors to actually choose whether or not they should actually invest in this country or that. And publicly available data allows firms and citizens of a given country to be aware of their context and to make informed investment and electoral decisions. Now let me give you an understanding of what is an indicator. So we wanted to build the indicator for Bangladesh, an indicator of quality of life indicator that will help us to understand how people in Bangladesh are doing. So we actually thought that okay, living condition, health, education, infrastructure, environment, these should be different dimensions of that indicator. And in this living condition, we actually thought that okay, we should have access to electricity, income, poverty, sanitation facilities, drinking water sources, etc. Put into this one. Then in health, we wanted to actually have understanding like birth registration, in nutrition, under five mortality as uh, as sub indicators of this indicator. So well, I mean, I'm not showing the other levels here, but you get the point. What we try to do is we actually try to aggregate different dimensions of data to actually get a value that can actually help us to ascertain how the country is faring over time, or cross section in a sense that how this region of the country is doing better than that other region. The problem in doing so is that the traditional data that we actually have are from varied sources, meaning that they are conducted by different institutions, and oftentimes they don't communicate because they are not done in the same year. They are not done in the same type of country, same areas of the country, because there are always samples that are used for this, and that's why these are not comparable. And then they are not frequently collected because these are very expensive, and that's why they are not frequently collected. So for living conditions in our data set, we actually use Hayes data, which is the data set, standard data set that Statistical Institute of each country actually gathers every 5 years. And the last available publication year was in 2016. Now, uh, the one that actually we have for to assess the quality of life of the country. But in case of health, we have data from 2017 because DHS, the data source, it is done every 2 or 3 years. The best data that we actually have, which is done every year from in terms of frequency, is the data on education and other some other multiple indicators, which are surveys conducted every year. So the best that we could actually get in a traditional way are data that are done every year. However, I mean the data sources that we have available are 2019. We are talking about we are now talking in 2021, and the data that of 2022 2020 is not available. So it means that we are basically not looking at present. Our indicator are always lagging behind. Now, what's the solution? Now, so was we what we have agreed on this thing that these things are not communicable, they are expensive, the traditional data sets, and they're hard to conduct frequently. The alternative, due to machine learning and computational social science and other different advent of new technologies, we basically have sources that actually can help us to gather data more frequently with less expense. Um, uh, uh, and 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 these things, I mean, these things can actually aid our data conditions in several ways, such as it may entirely replace the statistical sources, such as survey. They may partially replace the existing statistical sources, such as surveys. They may provide complementary statistical information in same statistical domain, but from other perspectives. They may improve estimates from statistical sources, and they may provide completely new statistical information in cases where we do not have any access to data, traditional data, that might say. All right. Now, let's take a pause and think about uh, what is the, I mean, what was going on when we didn't know how to show data and how to use data for public policy. All right. So here we will talk about maps, data, and society. It's a kind of like a story that, well, we are right now we are in COVID period, and we are going through this horrible condition around the world, lockdown in our house. But these, diseases came year after year. I mean, in the human history, we know a lot of times these things came and wiped away societies and nations. Cholera, which is an infectious disease caused by a bacteria, even in 1850s was kind of like unknown because the germ was not yet found, and people used to think that it's caused by miasma in the air. So it basically means that bad air or night air. So look at this picture of Robert Seymour, who basically is drawing this cholera here, and people are actually dying. Um, so in London, 1850s, there's this doctor called John Snow, who in 1854 actually, he basically thought that okay, let me see if where do the people actually die most. So basically, what he tried to do is like he put the map and then he started to tile the number of deaths. And once he found the number of deaths in here, number of deaths are higher than this place and this place. Basically, what actually was found that it was not the case that I mean. So basically, doing this actually helped him to understand why cholera was happening, right? Um, how? So what he was doing. So if we actually look more focusedly, we see that okay. So most deaths are near this pump. Workhouse had their own water supply. So what is this workhouse? Workhouse is a place is a distillery. It's basically they used to make their own beer. Now they had their own workhouse and they had their own water supply, and that's why in this area there was no problem, no death, and in this area there was a lot of death. What it points out to is that there must be a problem in the water supply system of London. So this is the map of London where this thing happened. And John Snow, the doctor, first time put the number of deaths on top of the map and then explain that the reason for having cholera is having bad water. So something in the water is causing this. Something in the supply water is causing this, because other places where you have their own water supply, they are not affected much. This was revolutionary. This basically changed the way we see maps, changed the way we actually make public policy. So now we see, uh, I mean, remember that at that time the germ, cholera germ, was not in. Well, it actually took another 2 or 3 years after that. They found the cholera germ, and they actually, proved that it is waterborne. Anyways, before knowing this thing, so the importance of data, this is how it is. And the countries, as now we are progressing into COVID situation, we actually have seen the countries that have taken data seriously, has taken better measures, taken decisions regarding locking down the country and the time when it is needed, or opening up at the time when it is needed. All right. So, so now we know the importance of data and how actually that helps the public policy. Let's talk about some of the work that we have done. So, we use this satellite data, nighttime light data. Uh, this is Bangladesh, by the way, to understand the inequality of um, uh, of of different regions of the country. So, if you see, this is the GIF of how the country actually, uh, over time, how nighttime light increased in Bangladesh from 2012 to 2017. However, we can see that this and this are the two spots where the light is getting more brighter. That means more electricity is being used in these places rather than the other parts of the country. It actually shows how regionally yeah, the energy use is unequally distributed regionally. Um, then, however, if we actually want to see it more granularly, we probably have to look at with another data source. Uh, Not the nightlights data. Nightlights data is from the satellites. There are problems like clouds, etc., that actually do not let us actually see um, um, the condition very well in different time of the time of the year. Now, if we have an access to the billing records of the households of the country, we can have better informed data. So household billing data, which is not, again, not a traditional data for doing any type of development statistics, rather than, of course, they are used by the utilities, but not for development statistics. We have shown that using that, we could basically can see different things in terms of uh, right. Sorry. So basically, that type of data actually gives us more vision. For instance, we can understand like the change in billing behavior. How is it possible? Well, in Dhaka, the capital city of Bangladesh, the government of Bangladesh actually introduced this new technique, new technology, intervention called prepaid bill paying mechanism. And while it was actually surrounding, not all the households of the country actually had this access. However, the way we people actually use prepaid is this. I mean, they actually go pay for the electricity they will be using over the next 1 month or something. So there are several different ways to do that. Banks, you can go and line up on a bank and pay. You could actually go to the electricity regional office to do that. You could actually go to different agents, basically small shops near your alley, and pay them. What actually we have found is that before the agent-based payment started, uh, we had this banks and electricity regional office. We actually found that most cases, like people used to be paying less on the weekdays, more on the weekends. But as these agent-based payments started, and gradually people started to actually pay less on the weekdays and pay more on the weekends, which means that these kiosks brought made the lives of the people easier. They could go and pay for their prepaid card as they wanted to, and weekends are the best time to actually do it, because normally what happens is that the banks are not open at the work time, and regional offices are not open at the work time. So this nuance actually of the payment behavior actually shows, and if we know it, it actually gives the information to the policymakers of that they should build more agent-based payment methods, better agent-based payment methods, so that people can pay when they want to. Now, a the there's this when we actually do this type of data processing and data work, we actually have to think about what data is usable for what. Now, as we actually have mentioned a little before, um, not all data is usable for different type of things. Now, if we can, if we look at this thing, we see that over time, regions of Dhaka city, this is the Dhaka city, actually have illuminated, of course. But if we want to use the nightlights data in comparison to this data might, this nightlight data might give you a false information, because the radiance is decreased in some cases and sometimes stopped due to cloud coverages. So we need to actually know, the problem of these type of data is that we really need to know before coming to any conclusion that if the data is suitable for this purpose or not. Okay. All right. So now that we know that, I mean, what else can we do? We could actually look at, like, if we actually use the billing data, we could actually look at that, where are the most consumers living. So we basically see that the most of the consumers are living in this area of the of of, of Dhaka. We could actually see, like, how seasonal change. Uh, I mean, in change basically uh, impacts the consumption of electricity. So, and then we actually can see that how yearly consumption changes over time. It was drastically changing now, and then it actually kind of like slowed down. So, cumulative density of households, how they actually change over time. So we, from this type of picture, we can actually know that 17% of the households have similar consumption, 30% of the households have decreased their consumption over time, 43% of the households increased their consumption over time. So, um, and then what we also can find out is that the utility bill paying habit actually over the are not the same for every month. So we actually can know, like, in January, July, and October, when are the months when most of the bills are paid. Most of the irregular payment has been done. So these are different type of questions that we want to answer in in Bangladesh in energy consumption context. However, the data that we actually showed you, the billing data, etc., most of the data are in this format. So this is the problem. So basically, these data are not in a format where that is readily usable for computation. So a big chunk of our work is to actually convert these data into digital format, digital data, and then do analysis, right? All right. Now, now that we know the importance of data and what data can do, what we actually shift to is the importance of mm, modeling. Look, here there are two models, right? The first model shows how flood happens. The second model also shows how flood happens. This is more accurate. With this model, you might think that we have to actually cover the whole area. If the flood happens, we might need to evacuate the whole area. With this model, we actually know that no, it's not going to be like this. When the flood happens, it will only cover some of these areas. So evacuation, we don't actually have to have a huge evacuation. So this is how important good data is. Right. So we talked about nightlight data. Let's talk about um, daylight data. Now, what we wanted to actually do is to actually use our daylight data, which is basically daylight satellite data, to understand how the cities are. Now, why? Because cities are getting exploded by people. Um, but we do not know how people are living, where they are living, and what is the living condition. So it is very important to actually know the living condition of the people. Now we have like two different type of city pictures. One actually shows like this is a very structural and formal space. This is very non-structural and informal place. Here we actually see this. This is the informal area, kind of. This is a very formal structured, well-structured area. So this actually shows like how different the different places of the cities are. Now this means that if we know better how the informal areas are, how they're growing, how they have changed over time, etc., we would be able to take interventions. For instance, like putting a school somewhere, having a hospital somewhere, building a road so that like the lives of these people actually change. So in order to do that, the traditional way to actually do this thing. I mean, so as I said, like knowing these things actually help us economically, environmentally, planning, and socially. Now, traditional way to do this thing is to actually minutely, go and do a survey and minutely design the space. We can only do a small area with this method, a very small area, because these things are done by hand. We have to do multiple surveys, and as you can understand, surveys take longer time, and then by the time it is done, it's conducted, we don't have enough time anymore. I mean, the whole place actually has changed. Probably somebody actually built more houses here over time. So this is always the situation of past. Now, um, um, so now this there is another method to do this. Right? This is based on the image data that we actually can get from the satellite, and what we could do, we could actually figure out those areas with human intervention, human eyes, right? Visual intervention, and then find out this is say that okay, this is the informal area, this is the more formal area, etc. So what we wanted to actually say that okay, it has, of course it has high accuracy, but it is laborious and it is inefficient. So we actually thought that okay, can we use machine learning for this type of thing? So what we did is like in order for a machine learning tool to actually work on, which is basically a deep learning tool that we are talking about, we basically had to categorize the city area into different types. So based on their architectural condition and based on their urban pattern, meaning that we actually looked at the building and its surrounding. Based on that, we could actually divide it into 16 different categories. And then what we actually did is like we used these things into like six different type of cities. So Guangzhou, Nairobi, Mumbai, Cairo, Jakarta, Lima, and also Dhaka, my native city. Um, and these are the different type of categories of the that are used for these cities. And just a sample, this is Dhaka. Based on these categories, we could actually put different colors. So see, like these are the red colors, this yellow and blue and green. They actually show how. Um, so these areas are here, here, here. These areas are here. These blue areas are here. So what it means that red are the highly informal area, more blue, so the darker blue is very formal area. So this is very formal area in Dhaka, and this is highly informal area. And people who are migrating to these cities, they basically go to the informal area. So this actually, and the beauty of this thing is like this is done by deep learning method. And so basically, what we actually have is we can learn and we could use it for different cities. So if we look at Nairobi, Mumbai, Jakarta, Guangzhou, Cairo, and Lima, we could actually categorize them and faster with the deep learning method. We could actually we can again like figure out different features of these things with this method. Um, and based on these techniques, what actually we can do is like we could actually figure out how these things are growing over time, right? Um, so um, so as I said, like, the process is very simple. We basically, in a city, this is the city map from the satellite. This is the ground truth, which is done by human gazing. Some human intervention is needed for this, and after that, we basically scale it up to the whole city, so that we now we here we actually use this for training of the model, and here we actually use it to get an output. All right. So now that we know how this data are used and everything, we have to actually think about, okay, so so what are the tools that we use? As I said, we use data and AI, machine learning, for for such purposes. And not only this, I mean, not only in this type of work, but also these things can be used for crisis response, economic empowerment, educational challenges, environmental challenges, equality and inclusion, all those SDG parameters that we actually were talking about. So now that we know the importance of this type of work, let's think about like how this AI process actually works. We know that we're using AI for this type of modeling for new computational stuff. So, but these are like it's a work of pipeline. First, we need to do that data acquisition. We have to do extensive data cleaning. We have to store data. We have to select features. Then we actually do a lot of visual analysis of the data, and then we do the modeling. And this goes iteratively over time to make the model better suited for the specific outcome. Now, but so I mean, if we do anything wrong in that in that modeling, there are risks of using this type of modeling mechanisms, because the risks are of different types, like societal, individual, organizational, and they actually come from, first of all, from data. If we have a wrong source of data, we are using wrong data to train the system, and then that means that the model becomes very, I mean, totally unusable, or gives you a wrong information. If we have a totally wrong algorithm for using the data, we might have output which actually makes no sense or harmful for the society. And then the interaction between the human and the machine is also important, because how we interpret the information, or how we basically design the problem, is also important in getting better information out of this AI systems. Um, and as I said, that the risks are high, and it might be a loss of life. It might cause, like, national organization security failure, damaged reputation, regulatory backlash, criminal investigation cases failures. I mean, you might, think that, okay, a bad guy becomes good, or a good guy becomes bad because of your failure to ascertain and use of, failed AI system. And at the end, it actually diminishes public trust on the system itself, right? So in case of, like, LULC work, which basically, when we talked about the land use, informal and formal use of city area, if we have any type of mistake in this type of modeling, we might actually miss categorize a formal area into an informal area, and then the public service officers might start designing something which actually doesn't cater to that area at all. So we have heard a lot of stories about AI failures. I mean, IBM, Watson on oncology failure is a classic one. Microsoft had that problem. Apple had that problem. Amazon had that problem. Everybody, all these big companies, actually showed they how they basically, their AI system failed to, I mean, because they were not well designed, um, and because of those problems of data, algorithm, and interaction. So basically, so how bad data thwarts AI success? Now, a lot of data is fed in the training, and to train the machine. based on which the computer notices a pattern, makes judgment and prediction. Data can be bad if data is missing or incomplete, data is inaccurate, and data is biased. Now, what is bias? So bias is this. Now, imagine in a system, in a machine learning system, what we actually have is that we basically have to teach the machine that okay, certain person is a certain thing. So, for instance, what we wanted to do in this picture is like we wanted to actually know who are the actors in this picture. Now, the coder who is going to be basically telling the machine that this guy is an actor, this guy is an actor, this guy is an actor. If he doesn't know that who is the actor, right, then he probably will think that, okay, this is the only guy in this picture who is an actor. However, if you know Indian actors, then these are these three are also I mean, are actors from different parts of the world. Now, so it means that um, when we misclassify um, or when we actually I mean before feeding the data to the machine, we really need to make sure that the data that we are feeding is right and it is classified by someone who actually knows the thing. If it is done wrongly, then this data fed into the machine will always give you wrong answer. Okay. All right. So from there, let's think about what is the biggest problem. The biggest problem is that having that type of bad data fed into your system, and then building new technologies like with deep learning machine can actually make a disaster, right? But then there is another side of the story. There are places, there are tools. I mean, now we call up a thing called deepfake, where we could, I mean, you could actually use that tool to fake anything. So you could actually put a face of a person, change it into a dog, and then start the dog talking. And it's funny. However, I mean, it can be malicious because then, I mean, you could use it to basically vilify a person. You can do face swapping, swap the face of a president um, with a bad guy, and then you make a video that make it viral, and then people would think that this was done by a good this bad thing was done by this good guy. So then there are other things called face to face, like um, where we basically do like totally impersonalization by another person, um, and you doing a face swap. Lip sync, like using the mouth articulation replacement linked to different discourse. So basically, right, what I'm talking now, you can use this lip sync technology and then change it into a totally a different thing. Um, I mean, and even if I didn't say it, you might record something which basically what was not said by me. So these things are basically destroying um, the situation. I mean, these things are. I mean, of course, they have good impact on the society. Of course, if they're used better for better purposes. For instance, in movies and for other cases, they have been used. However, there are malicious uses of these things which we need to actually really take care of as well. Um, so basically, now we actually know that the algorithm that we are trying to actually design can um, can actually make a difference. So we could actually use the algorithm for malicious purpose. We could actually design it for good purposes as well. Now it can. So this is the algorithm. This is the thing called algorithmic bias, which is in the design of the algorithm. You have a good data, but if your algorithm is designed for malicious purpose, it might give you a bad result. Okay, sometimes it is not even malicious purpose. It's just because the engineer or the designer is not knowledgeable enough to actually use what algorithm for what data, and that causes disaster as well. Right? So, so that at the end actually takes us to this idea of AI fairness. We have to really remember that algorithm that performs fairly on your old data set may not result in a system that will perform fairly. It means that we, of course, even if we have more representative training data, even if we have regular auditing of your bias in your system, etc., you try to be very prudent on choosing the algorithm and data, etc. There are chances of failure. So we have to be very humble in thinking and noting that whatever results that we're actually getting from our tools probably are not may not be the best or needs to be redone uh, frequently enough. And human intervention is very much needed to see how these things are faring. So basically, uh, so uh, basically that's what I actually wanted to cover today in this course. Thank you so much for your time. I hope it was interesting for you. And if you have any question, you could actually always email me in this email address. Um, Again, I'm very humble and very pleased to be with you. Ni hao. And yeah, I see you soon. Thank you so much.